To finish off our discussion about supernovae, I'm going to bring up something called gamma ray bursts. And your book covers gamma ray bursts somewhat in a much later chapter when it's talking about cosmology and distant galaxies. But they actually fit in with our discussion here of supernovae. What's going on here? In the early days of the space exploration, the military realized that satellites are the ultimate high ground for surveillance. So you've started having military surveillance satellites. One of the things they were going to do was search for enemy nuclear tests, or in the Cold War, other countries' nuclear tests to measure what they were doing with nuclear weapons. And so they were able to detect X-rays and gamma rays given off by nuclear weapons. Well, shortly after the first one were launched, they started detecting these anomalous bursts of gamma rays, except they were not corresponding to nuclear weapons tests. And they began to realize the bursts were coming from outside the solar system. And so astronomical satellites then started mapping these things, and this is a map of the sky, and you see them in all directions of the sky. They're no one particular place. That means they're not confined to our galaxy. They're from all directions. Our galaxy, preferentially most of the galaxy is one way compared to the other. These are everywhere, so that means they're not part of the galaxy. They're from deep space, intergalactic space. And this gives you an idea of how powerful they are. They were picked up from well outside our galaxy, millions, hundreds of millions, billions of light years away, and they were picked up by detectors designed to detect nuclear weapons only a couple hundred miles away. And so that gives you an idea as to just how powerful these things are. And for a long time, they're just complete mysteries. And then um, 1997, there was one that went off, and they were able to find a little bright spot in the sky right where it was coming from. And then that bright spot faded, and they were able to see a barely visible, tiny little smudge that was a galaxy there. And so the galaxy was so far away, it was barely visible even in our best telescopes. And yet it was a gamma ray burst that was comparatively bright. Since then, there have been several other galaxies associated with gamma ray bursts. So, what's going on? What could make a burst that's this powerful? Well, Craig Wheeler down at UT Austin worked this out, and it turns out it is actually likely to be a supernova, a supernova. One could even call this a hypernova. So, an extra large supernova. And so, this extra large supernova, the core collapses as stuff is spiraling into the core. Then you get these beams of radiation that are coming out. Again, this is like an accretion process as stuff spirals in the collapsing core for a supersized massive star collapse. These beams go out, and if you happen to be along one of these beams somewhere out here, then you get a gamma ray burst. And so that's how you see them from so far away. Now, the good news and bad news is that means you can see them a long ways away. Good news, bad news, if you're anywhere within 10, 15, maybe 20,000 light years of this thing going off, if you're right along that beam, you get fried by the gamma rays. So they're exceedingly. So the collapse produces something like a black hole in the middle. We'll talk more about black hole later, but just as it's producing it, you produce these giant bursts of gamma rays. And again, you could call this a hypernova. Wait, that's another type of supernova. So now we have Walter Body thought there was like 5 or 6 different types of supernova. So we have type 2 supernova. We have type 1A, type 1B, type 1C. That's 4 types right there. And then we have type 1, 2, that's type 5. And now we have this, which is a 6th type. So that kind of verifies his original ideas. When the beam is directed towards us, you see the burst of gamma rays. And interesting thing here is that in 2008, on March 19th of 2008, there was a gamma ray burst. And that gamma ray burst was detected by the Swift X-ray satellite that was monitoring that part of the sky at the time. And the afterglow, the bright patch there, peaked at about just under magnitude 6. That means technically it was naked eye visible. Not for very long, for less than a minute maybe. If you're looking at exactly the right spot, there's no record of anyone actually noticing this barely visible little speck out there. But technically it was. But the host galaxy where this thing came from was 7.5 billion light years away. That makes this object the most distant potentially naked eye visible object in the entire universe for at least, less than a minute or so.